Hi guys. So today we're doing question 4, which it's the momentum graph type questions, of which you have to pay attention for this one. This ones are more important because now we are applying what we learned. Right. Now let's begin. So Q4. Let's read the question statement. The graph below shows how the momentum of car A changes with time just before and just after a head-on collision with car B. Now car A has a mass of 1500 or 1500 kilogram, while the mass of car B is 900 kilogram. Now car B was traveling at a constant velocity of 15 meters per second west before the collision. Now take east as positive and consider the system as isolated. So this is the graph we're given. Now what does this graph show? The graph shows what how the momentum of car A changes before it collides with car B. So this is basically the momentum versus time graph for car A. Okay. So they ask us this important question. They say 4.1, what do you understand by the term isolated system as used in physics? This is a very important question because we don't usually ask this type of questions. Alright, so to answer this, an isolated system basically is a system where the resultant force is zero, right? It's isolated from its environment. There's no factors or other forces that are affecting um, the system. So basically, that's an isolated system. So the answer for 4.1, it's a system on which or in which the resultant or net force is what is zero. In simple words, in simple terms. So 4.2.1, they ask us to calculate the magnitude of the velocity of car A just before the collision. So they want us to find the magnitude of the velocity of car A just before it collides with car B. Now how can we do that? Now to do that, we firstly have to find what was the momentum of car A before it collides with car B. I'm gonna use this. So the momentum before it was what? It was 30,000. Right? What is the mass of this object of this car? Is 1500 or 1.5 or 1500. Then the velocity of which they want is at this point before the collision, which is 20. Right? Good. You're gonna get a mark for here and here and here. Substitution. Right, now calculate the velocity of car B just after the collision. Just after the collision. Now for that one, it's going to be a little bit tricky if you are thinking of using the momentum formula, because you can't. You just have to use the principle of linear conservation of momentum. So the sum of momentum before is equals to the sum of momentum after, of which we know that did they move together or what? Nope, they didn't move together. If they should have told us if maybe they collided with each other and moved in the same direction, or they became one system. So since it's not that case, we're gonna say mass of car A V initial plus mass of car B V initial, which is equals to mass of car A V final plus mass of car B V final. So mass A, what is mass A? Of car B. What was the question? The velocity of car B. Okay. So did they give us the mass, the mass of car B? Yes, they know they didn't, right? But then it's no issue because we have the momentum graph here. Okay, good. So what is the momentum of car A? Oh no, we do have the mass of car B, but we just to clarify what I just said. Couldn't see it. Okay. So we know the momentum of car A before is what? It's 30,000. Then the momentum of car B, we don't have it, so we are forced to calculate it. It was what? It was, it is 900 times negative 15, right? Because of this. And since they said take east as positive, it's moving west, so it's negative, right? So the momentum after, it was what? It was 14,000 after the collision. and for B it was 900 times what, the VF that we're looking for. So you're going to simplify it by adding up the 30,000 with the 900 times negative 15, and then you should get what, should get negative 105,000, right? Then you're going to subtract the 14,000. Then you're going to divide your answer, the answer that you get, with 900, which your VF is what, is 2.78 meters per second. That's the answer you should get also, by the way. Yeah. Right, now okay, yeah, here this one it's not 5, it is 6 5, it's not negative, also 500. You will, and this answer divided by 900, yeah. Alright, so this is the answer, by the way. This is the VF, just made a mistake here. Alright, so for 4.2.3, calculate the magnitude of the net average force acting on car A during the collision, right? So I want us to find the average net force, of which to find that you just look at the gradient of this graph. The gradient of this graph, it just gives you F net change in P over change in T. At the day one average of car A during the collision, so between this point, you know that what was the momentum. Use the final one, just 14,000 minus 30,000 divided by the change in T, which was 20.2 and 20.1, of which you should get 160,000 of net newtons, of which is 160 kilonewtons. Right. Yeah, you're not forced to write it like this, please. This is just scientific notation, by the way. Yeah. Good. So we've reached the end of this video, and I hope that you understood and you enjoyed as much as I enjoyed making this video. And if you have any inquiries or if you don't understand, please leave a comment below or email me in the email in the channel about, right? So just like that, guys, I'll see you in the next one.